Happy day, digital world. I have another set of amazing questions about the outstanding data visualization assignment 2. I'm really happy that everybody is working hard on the assignment, and I can see the great efforts and the progress each time I check my email, and yeah, it's very exciting. So I'm sure that this video is going to be very, very helpful. I'm going to give a lot of answers out in this video, and maybe too many actually. So this is questions 36 through 43 so far. Dear Professor Laramie, I used a converter to make betty.raw a .png file, which I am attaching to this email. The resolution that you mentioned in the metadata is 128 by 32 by 64 for X, Y, and Z, I assumed. I create images of resolution 128 by 32, but I don't recognize something that tells me that I did it correctly. It's like patterns on patterns without clear separations, with the exception of every 128 columns. For every row of the image, I read every j times 128 plus j plus 1 times 128 for j equals 0.7 pixels and stack them together in a column. I do this for 4 rows to create the image. Is there something I assumed wrong? Is the image okay? Okay, yes, I looked at your images and you are correct that the images are incorrect. The images basically look like very noisy to me and almost like random noise. So here's what I have to say about that. Firstly, you said you used a converter, right, in your first sentence. Well, my question to you is, which converter did you use? That's one question or one comment I have. And then you say you converted betty.raw to a PNG file. Okay, you can do that. However, I just want to also mention that this step is not necessary. There are some volume visualization software applications that can read .raw files directly if you tell them the resolution of those .raw files. One of them is called ParaView, right? So ParaView can actually read in the betty.raw directly and visualize it for you. And the other question I would have is, what software did you use to view the images? Right, so without knowing what software you use to view the images, it's also a little bit harder. But I think you're making your life a little bit more complicated than it needs to be. .raw is a file format that several programs can read already. So you could, for example, Google programs that read .raw files. I'm also going to suggest that you watch the rest of this video and some of the other students' questions, because I think the answers to some of the other student questions are going to help you with this as well. Question 37. Hi Bob. I've been looking at the visible human dataset for assignment 2 and found this website. It's https://mri.radiology.uiowa.edu. So it's the University of Iowa Radiology Lab. And I can put the URL in the comments of this video for anybody else that wants to see, which has the visible human dataset as individual DICOM files or TAR files for different parts of the body, male and female. Do we have to use the website link you provided in the assignment brief, or is it okay to use this website, such as the one above, for the last part of the assignment? So my answer to that question is yes, you may use that data set that you found, the visible human data set that you found, which is on an alternatives website. Also in the assignment brief it says, quote, 2 different volume visualizations. Do we have to do 2 different visualizations on 2 different volumes, like the head and pelvis? Or is it just 2 different techniques on 1 volume, for example, DVR and isosurface? The correct answer is your second guess, which is 2 different visualization techniques on 1 volume, for example, direct volume rendering and isosurfacing. So easy questions to answer. Question 38. Good afternoon, Bob. I've started working on volume visualization with Voreen and InVivo. I have currently visualized the walnut and human head datasets. However, I am slightly confused about what kinds of observations to make about this data. For the head, I can see some interesting left-right symmetry, and for the walnut, some asymmetrical and spiral patterns. Are these valid observations, and am I on the right track? Could you please advise either way? So the idea behind the unique observations is just to encourage you to make an interpretation of what you see. It's for me to know, okay, does this person know what they're looking at? Like, when you're looking at that thing, can you interpret anything? So for example, with a walnut, you'd want to Google like the anatomy of a walnut, right? And Wikipedia will have a page on the anatomy of the walnut, and that will tell you what the different parts of the walnut are, and then you can see them in your own visualization. You can say, oh, now I see this part of the walnut, right? So you can understand what it is you're actually seeing and looking at. You can also look at the examples of unique observations from assignment 1, right? So the unique observation parts for assignment 1 and 2 are the same, and I provide an example of a unique observation for assignment 1. You can also look at the assignment 2, right? So assignment 2, I provide an example of a unique observation in a volume visualization setting for more guidance on that. But basically, you want to convey to me that you understand what you're seeing and you can say something about it, right? I don't want to just give you an answer or tell you the answer, because I don't want to actually start doing the assignments for you. Question 39. Hi Bob, I'm using ParaView software and currently working through the tutorial they provide. I was wondering if for the first 2 visualizations, is it the dataset I should use? To clarify, should I follow the tutorial and then use that dataset, create 2 visualizations and use them? Thanks in advance. So the short answer is yes. You can use any sample data set that is provided by the volume visualization software you are using and trying out and testing. That is the idea, right? You want to make sure you have the software installed correctly and working correctly, and the best sanity check for that is just to render one of the existing data sets that the software uses and recommends for a demonstration. So yes, any example data set that they provide is fine. Question 40. Dear Bob, I've had quite a few problems getting Sally to work. After a lot of head scratching, this is my code for Sally. Maybe you could tell me what you think of it. I'm then assuming from your answers on your videos that I should pass 32, 32, 32 as arguments. Question mark. When I do, this is what I get as my results. See attached. I'm not sure if this is what I'm supposed to be working with. Am I on the right track? Question mark. Thanks for the help. So I have a lot of things to say, helpful hints for this question, because Sally seems to be really mysterious for a lot of people. So your first part, I should pass 32, 32, 32 as arguments. That is almost correct. I've drawn a little image here of samples. So what you want to pass is actually the resolution of the data set, right? So the X resolution 32 is correct, the Y resolution 32 is correct, the Z resolution 32 is correct, but you forgot the time parameter, which you need to set to a constant. In this example, I set it to 1, right? So you're passing a resolution of the data as input to the gen Sally function. Can be 32 cubed, comma 1, 64 cubed, comma 1, 128 cubed, comma 1. 32 is a good thing to try, just to make sure it's working, but it's not going to give you very good resolution images of Sally. 128 cubed is going to give you a well-defined Sally, so to speak, with enough resolution to really understand. Also, now I cannot tell you by looking at the numbers you showed me. You showed me this 3 columns of numbers. See, this is exactly the point of data visualization. Actually, I cannot tell just by looking at those numbers if they're correct or not. I need to actually map them to some visual layout. If you had showed me those numbers on a scatter plot, I could have told you if they're correct. But I can't tell you. There are too many for my brain, my visual system to process in order to tell you that they're correct or not. I'll give you some more hints though. If you take the 3 components, you sent me 3 components to the Gen Sally, they should look like this. Very, very approximate, by the way, very approximate. One of the components should look like a sine wave, for example. These are the 3 components, X, Y, and Z. One of them should look like a cosine wave. I may have got those 2 mixed up. And a third one should look very, very roughly just like an increasing value, right? And this is, by the way, this axis is increasing value. So increasing value and amplitude on the y-axis. So if you were to plot out the X, Y, and Z components of Sally individually, the profiles you would get would resemble something like this. Yeah. So that's another hint. And another big hint is there's a file inside the Sally folder called Sally Hints. Read that file, like with your eyes. So that file, sallyhints.txt, contains a lot of extra explanation about the data set, what is you pass in, how the function works, and what it stores and everything. So definitely look at that, because I think the answers to all these questions about Sally, I think, are basically in the Sally Hints file. Okay. Question 42. Hi Bob, I tried another VTK file in ParaView and got the correct image. I have also tried saving the Sally data as a CSV file, but get the same output as the VTK. I have no idea where I'm going wrong. I have attached the code that creates the CSV file. I have checked the ParaView documentation of my CSV file is in the correct format and it works with ParaView correctly. Any advice would be greatly appreciated. So I hope that the answer I gave to the previous question helps, right? So the gen Sally function takes the positions of the samples, for example, 0, 0, 0, 1, and outputs the x, y, and z components of the velocity vector for that sample, right? And there's an inner for loop for the x values for the x dimension. The second for loop is for the y dimension, and the third for loop is for the z dimension. My advice is read the Sally hints file. Try out a sample pair view file. It looks like you might have done that, but just to be clear, make sure you have tried out a sample pair view file that comes with the software and you can see images that are correct, right, to make sure it's not a problem with the software. And then once you know you have a sample file that comes with ParaView, that comes with the VTK working, and you can see correct images, compare that file with the one you have generated to see if you can find any discrepancies. And then, of course, you want to double check the documentation for ParaView and the VTK. So they both are very, very well documented, and they provide online documentation about file formats and all these things so that you can double check to make sure. And the last thing is we do have one more lab before the assignment, so you can come to the lab and the teaching assistants can help you as well. Question 42. Hi Bob, for Sally I have a CSV file of X, Y, Z time magnitude and have imported it into ParaView. I tried doing magnitude in there, but it wouldn't work and have managed to render this using table to points. However, it doesn't look right and I wondered if you could offer some advice on what I might be doing wrong. So there is a problem with the image you sent me, and there's a problem with the question, because you said I have a CSV file with X, Y, Z time and magnitude and imported it into ParaView. You don't need to pass 4 parameters into ParaView. ParaView can derive the magnitude from the vector automatically. So that's not necessary, right? My answer to this one is very similar to the answer to the previous email. Make sure you try out ParaView with an existing example data set or CSV file if you want to use CSV that you know works, right? That's the whole idea. That's the whole idea behind part 1, is to make sure that the software is working with an example that ParaView supplies, right? Once you know that's working, you can compare your input data file with the example that you know is working, right? And then you can see the difference. And of course, you would double check the ParaView documentation guide on inputting CSV files into the application software to make sure you have the format correctly. So based on a comparison with a correct file and based on your consultation with the documentation, you should be able to spot the problem, right? And also there's a lab next Friday on the 20th of April. You could come in and the teaching assistants can try to help you out, but hopefully that won't be necessary. Question 43. I've fixed the output of Sally and want a slice as a visualization example. However, the slicing tool, in my opinion, doesn't work well with this data set. I have Sally plotted with glyphs. Instead, can I use the clipping tool and describe it as slicing? The reason is that clipping provides a visual with more substance, where slicing is sparse and only produces a few points in that visualization. The answer is yes. Of course, you can use clipping, and you don't have to describe it as slicing. So any volume visualization techniques basically are fine. So you're not limited to just isosurfaces, direct volume rendering, and slicing. There are other methods you are welcome to use. Okay, I hope that next round of questions really helped, and make sure you check out the sallyhints.txt file in the Sally folder online. And please let me know if you have more questions. Thanks for watching.